My name is Scott, and this is my channel, Big Thumb Industries. I'm just a random guy who has random hobbies and does random projects. Today, my random project is rebuilding a part for my riding lawnmower that I broke when I was trying to change the brake pads. So come along, maybe learn something new. It's going to be a great day.
Craftsman 17.5 horsepower mower. This is not exactly the same one as the one I'm attempting to fix, but about 98% of everything stays the same, even though there's about 100 different model numbers of these mowers. Pretty common in Canada. Obviously from Sears, was our go-to store for many years. Anyways, here we go. So basically on these Craftsman mowers, we have a disc brake off the transaxle, and the disc is has brake pads on both the front side and the back side, and we use this lever here, which has got a curve in it that will, when pushed, will actually insert pins on these brake pads and push this disc and then break this disc. So it's a brake and a clutch, in the aspect that you brake the engine, you brake the transaxle, it'll stop the wheels from turning. But what I didn't realize is that you're also supposed to be stopped before you shift gears. This mower doesn't have the option to shift on the fly. This 26 is a spring that attaches to this bolt and then attaches to this arm. That's the return spring, and then this spring is on the activation rod, which is over here. Oh, sorry, out of view. And that is what you use with the pedal, and it pushes the brake on and off. When I was replacing the disc pads, I got a little rammy with these bolts, and this being just a magnesium part, I broke it, and upon looking for one on the internet, I couldn't find a replacement part for it. So this is how we went down the road of manufacturing our own and reinstalling, and some of the trials and tribulations I had with that. So I started the rebuilding of this brake caliper by measuring the old parts with a set of calipers, and I developed this sketch in Fusion. And you can see that this is going to be the hole for the bolts, and these are the holes for the pins. My Fusion experience has... Fusion 360 is a great program, but my experience is from the Autodesk program called Inventor. That's what I learned in college. So this is a lot like Inventor, but I am by no means a Fusion expert, so I can just muddle my way through this. So all I did was extrude this out so that we could extend both these columns to be pins, or for the bolts. Then I went one way with the other extrusion because we need this hollow cavity for the brake pad, and then I filled it out the other way, and then tapped the this is for a tap bolt to hold the caliper that puts pressure on the pins that go in these slots. And if we see here, we have the cavity at the back that holds the brake pad. So from this 3D model, I sent it to a friend who built it out of plastic on a 3D printer. We went back and forth a couple times and to get a model that worked properly. And from that, I created a drawing. So the drawing is what the machine shop needs to work off of. So you make a drawing, it basically just, from Fusion 360, you can make a drawing very simple by using the new drawing option from the design. And this is the drawing I created that I could send to PCB Way to get something built. You have the drawing application started, you just bring over your model and then you take pictures, you use different views, and you create all your dimensions. And this is the information that I needed to send to PCB Way for them to manufacture this. So basically this would be what you would use to manufacture at any machine shop. I found it very easy to make a drawing from this. By no means is this a tutorial on how to use Fusion 360 or use drawings. This is just the way I did it, and you can obviously watch guys that do this all the time on how to do it better. But this is an easy way that I found to make engineered drawings that I could give to a foreign manufacturing company and create my device. All kinds of services out of China. You can get PCB printing, you can get 3D printing, you can get CNC machining, you can get sheet metal work, but also and many different types of materials. I got mine done in mild steel because I wanted strength, but I should have went with aluminum because it would have been lighter and just as strong. One thing you can do with PCB Way is actually upload and share your files. So if you go to the sharing aspect of it, you can actually find my drawing and actually get your own part ordered or download it and 3D print it. I think this is a great, I don't have any connections with PCB Way. I just think it is a great way to get parts manufactured when you don't live anywhere near manufacturing center. Kudos to the Swedish maker who put me onto this, and I was pleasantly surprised that my part only cost me $65 American and was here within 2 weeks, which is way less expensive and actually probably shorter shipping time than if I was to actually order a stock part from a company that was selling parts. So if you're looking to make a custom part, this is a good suggestion. So this is the part that broke. There's the 2 bolts that hold it. Split apart there when I over tightened it. It's cast magnesium or zinc. These 2 push pins, they go in the center. So after I got that, I got a 3D model. Got a friend, Blaine, thank you, to print this off. And you can see that everything works. These pins were a little tight, so I increased the size of that dimension before I sent it off to PCBWay.com. PCBWay.com is a website, not sponsored, that will take your drawings and convert them into parts. So this is the parts that came in the mail.
This came in approximately 2 weeks from order from China to my door. Fortunately, I only got one built, so there is no others. I'm excited to see this. And there it is. And it is heavy duty. I made this out of mild steel. I considered making it out of aluminum, but I kind of wanted something that was robust. So bolts go in there, pins, oh, they slide like butter through there. And then our adjustment plate will be bolted into there. I don't have the right thread bolt yet. So this is mild steel. This is plastic. Finish is good. No apparent defects. Cheaper than getting a machine shop locally to do this. This is one of the first projects I started working on when I decided I wanted to make a YouTube channel. So it was like over a year ago I got some of this footage put together, and well, to be honest, I didn't get a really good vantage point for a lot of the footage, and so we're going to have to just watch what I did and make the most of it. Here I am trying to remove the dust cap that holds the lock washer on for the wheel, and I struggled with this stupid rubber dust cap. I had pry bars and screwdrivers trying to get it off, fought with it for a while, but finally it came off. And very simple to remove the wheel once you get the dust cap off. Just undo the circle clip and the washer, and then off it comes. The wheel comes off really easy. You can see I have the brake disc mounted onto the shaft, and I also got the brake pad bracket mounted, and now I'm inserting the pins that drive the brake pads against the disc. Those pins are driven by this brass colored bracket that pivots on a center pin. This is where I found out that I made a bit of boo-boo on the manufacturing of this brake pad bracket, and that I made the pivot hole for this brass colored bracket too large, and the hole on the bracket was not big enough. And this is where I spent probably 30 minutes trying to drill an oversized hole into that bracket so that I can mount a bolt that I had that would fit. I don't know what that stuff was made of, but every bit just skated right off of it. It was a real fun time. So to mount that pivot bracket, I cut the head off a bolt and cut a slot into it, and then I could use a screwdriver to set that bolt into the bracket, into the brake pad bracket. Then I use a nut on the bolt to set the back pressure on the brakes. If you set too much pressure, obviously your brake pads wear out. If not enough, then it doesn't activate. There I installed the backup spring. It's just looped to the back of the one bolt and onto the bracket. And now we have to set up the tension on the brake pedal. I gotta just set the brake pedal tension so that we're just getting a little bit of contact with the brake pads, and we adjust that tension by adjusting the nut on the upstream of the spring there and on the rod, on the brake rod. And finally we get to test it out. Works great. Mowed all the last summer with this mechanism and no issues whatsoever. Thanks for coming along.